Hi there. So in this video, I want to introduce your next take-home assessment 20 questions. So for this take-home assessment, we're going to be working on this game of 20 questions, which is a game you may have played before. It's a little handheld device or a website you can use, where a computer will ask you a series of questions and try to predict which object you're thinking of. So you think of an object and it asks you questions until it guesses right. So we're going to represent this game of 20 questions as a tree. So let me start off by showing you an example tree for what a game of this of fewer than 20 questions, but a game of this would look like. We'll ask you a series of questions. Is it an animal? Yes or no? And then if you answer yes, it'll ask, can it fly? Yes or no? If you answer yes, it'll then guess bird. So we have a series of questions and a series of answers inside this tree. Let me show you real quickly what it looks like to run the program. So I have this in JGraphs, so I'm going to run questions main, compile it, and run it. And then it'll ask me, do I want to start with a previous game or a previous tree? So I'm going to say no right now. I'm going to start from scratch. And then it will ask you, when you start from scratch, the first object in the game is just the word computer. So that's the only object it knows about. So it's going to ask, am I thinking about a computer? And let's just say for this example, I'm thinking of the word puppy. So since a puppy is not a computer, I'm going to say no. And then it's going to ask, okay, well, what object was I thinking of? Well, I'm thinking of a puppy. And it asks me to distinguish between, or make a question to distinguish between a puppy and the object it guessed, in this case, computer. So a question I might ask is it cute? Because puppies are cute and computers are not. And then I say, what's the answer for this question for my new object? Well, the answer is puppies are cute, so I'm going to say yes. And now it will update the kind of game state so that it now is aware of puppies, and this question I just added, is it cute? So let's go again. So let's suppose I'm still thinking of puppies. It will now ask, is it cute? And if I say yes now, it says, oh, was I thinking about a puppy? And if we were still thinking about puppy, we could say yes. And then the computer will say, great, I got it right. Now, if we were thinking of a different object, maybe a cat or something else, then we have to come up with a new question to distinguish between a puppy and that thing and so on. So all of this is represented by a tree in this game. A tree of a series of questions, and the leaf nodes are answers. So the game kind of goes down the tree, answering yes and no, depending on what the user is inputting, and then outputs whatever's there. And if it gets it wrong, it needs to modify this tree to add a new question and that new answer. So your job in this assignment is to implement this tree and all the methods necessary to play the game. So you're going to write some methods, namely a constructor that starts off in a new game with just the word computer. Now, if you want to use a previous game state, we have this method for reading and writing a game to a file. So reading from a file and writing to a file. These methods will replace the current game, or the read method will replace the current game with whatever was from that file. So let me show you real quick what I mean by these file formats. So this tree here, if you were to save it to a file using the write method, would save to a file called questions.txt that has all of the questions and answers written down. Okay? Now, it has them written down in a very particular format. It's going to be written in a pre-order traversal, and we'll use these like Q and A's in the file to signify if something's a question or an answer. Okay? So part of your assignment for the write method is to take a tree and save it to this file format. And for the read method is to take a file and then turn it back into the tree. So those are going to be two parts that are going to be that you're going to be working on for the assignment. And then the final method that you're going to be writing is this actual one that has to deal with asking questions down the tree. So the ask questions method starts at the top of the tree and goes down the tree following yes and no, depending on what the user is saying. And if the computer wins the game, prints a message doing so. And if they lose, then we'll update the tree based off prompting the user for a new object and a new question. Okay, so these are the four main methods you're going to be writing for this class: the constructor, read and write, and ask questions. Okay. So in this assignment, one thing that's going to be really important is making sure that you're getting your output to match our expected output, especially the ask questions method and the write method. You need to be formatting these things in a very particular way. So the output comparison tool and these spec examples are going to be really, really helpful here. Okay. So this spec also walks through what would happen in a case where the computer loses the game. So if the computer guesses something wrong. So for example, suppose we had this interaction where the user says, answers a series of yes and no questions, and then the computer guesses if the object is a bicycle. So it started at the top and went down until it hit bicycle. Then it asked, was it a bicycle? And the user said no, so they prompted them for a new object, in this case car, and a question between them, does it get stuck in traffic? And cars do get stuck in traffic. And here what the spec is showing you is what the tree looks like afterwards. So before we went down, started, is it animal? No. Does it have wheels? Yes. And got to bicycle and prompted the user, is it a bicycle? They said no. And so we replace this node with a new node for the question, does it get stuck in traffic? And then the yes side of that is the object the user has created, car, and the no side is the old one, the bicycle, because the user said yes was the answer to their question for their new object. Okay. So in terms of a development strategy here, what we recommend is before you begin, go ahead and just write all of the method headers for all of the methods. Don't worry about implementing all the methods from start, just to make sure that questions main can compile. Then we recommend actually trying to write your question node class. So one thing I mentioned is that in this tree, you need to keep track of information about these questions and answers. So what you're going to be tasked in doing is writing a node class called question node, kind of like how our tree int tree had an int tree node. And you have to decide what types of things to store in this question node, but we do require that you make your question node one of these private static inner classes. So I recommend looking at the int tree example from Wednesday, where we actually wrote this private static inner class for an int tree node. But you get to determine which fields go inside of that. Okay? So you're going to be writing that question node, and we recommend doing that for step 2. So decide what things you want to store in your question node, and what fields you're going to want in your questions game, so the main class, and setting up that first constructor. Then once you have that, we recommend write tree. Write tree is going to be the easier ones of the remaining methods. So please start with write tree to get used to what is your question, how you're going to recurse on your question nodes. Then we recommend doing read tree, so reading a tree from a file. And then finally, the most challenging method will probably ask questions, and so we recommend doing this one last, once you have the ability of reading and writing a tree. And as a reminder, kind of during each of these steps, make sure you're using the output comparison tool to make sure that your tree has the right outputs here, because that's going to be very helpful. And the mark tests on Ed are not going to be as useful here. Okay, so a couple of useful things to know outside this development strategy. So one thing that you might see in a lot from this output is you're going to have to ask the user yes/no questions a lot. So we actually implemented a private helper method for you called yes2. You give it a prompt, and it will print out a question and ask the user for input. So in the starter code for a questions game, we've already included this yes2 method. And we ask that you leave it here without modification. We want you to use this method as provided. Okay? The specification walks through that this method makes an assumption that you have a particular field for a scanner, and it talks a little bit more about that. You should have a field for your scanner input for the user. But this yes2 handles all of this like logic of actually prompting the user for things. Okay? So that's that first thing. The other things to keep in mind is when you're writing these methods, make sure that you're using the x equals change x pattern appropriately, so you can reduce redundancy. Okay? So we talked a little bit about how you should avoid morphing nodes, so you shouldn't change the data fields once you create them. You really should be rearranging the links in the tree, kind of like the pictures show. And the spec walks through some other things as well here. So this is a quick reminder, the output comparison tool here will be a very, very helpful tool. And then also, again, like always, you can code on Ed or you can code on JGrasp.